Hi, I'm Julian Leonard. My Panther ID is 6060871, and I'm going to be solving the exam 2 video question for you today. Okay, so we're going to start with 24.64, and it says a parallel plate capacitor is made from two plates 12 centimeters apart on each side and 4.5 millimeters apart. Half of the space between these plates contains only air, but the other half is filled with plexiglass of dielectric constant 3.4. An 18-volt battery is connected across the plates. Now for part A, it's asking for the capacitance of the combination, and like the hint says, this capacitor is essentially two capacitors in parallel. So the way we can think of it is using the equation C is equal to epsilon naught times the area over the distance. But because we're dealing with things in parallel and it's two separate capacitors, we are splitting into two parts, and we're also using K, which in this case is the dielectric constant. So our equation for the first one will be epsilon naught times K times the area times, 1/2 the area, because it's two parts, right, over the distance, right? And then C2 is going to be the same thing of epsilon naught times K of 1/2 the area of 2. Let me just specify this is the area of 1, that's the area of 2, over the distance. So essentially for C1, we're going to have 8.85 times 10 to the minus 12 times K, which is your dielectric constant, as they gave us, so 3.4, times the area, 1/2 the area, which in this case, the area of the first is 0.0144, and we're obviously going to divide that by 2, so times 1/2 over the distance, which is given to be 4.5 times 10 to the minus 3. And this is because we converted it from millimeters to meters in the case of distance. And when we calculate this, we get a capacitance of 4.817 times 10 to the minus 11 farads. So we're going to do the same thing with C2, 8.85 times 10 to the minus 12 times, again, the same constant, 3.4, times, this time the area is 7.2 times 10 to the minus 3, and obviously we have to divide that by 2. All of that is over the same distance of 4.5 times 10 to the minus 3, and that gives us a capacitance of, I believe, of 1.42 times 10 to the minus 11 farads. And because this is in parallel, we can simply add them together. Say 4.82 times 10 to the minus 11 plus 1.42 times 10 to the minus 11. That is equal to 6.23 times 10 to the minus 11. Okay, now part B is just asking how much energy is stored in the capacitor. So this is pretty simple as well. We're just going to be using the energy equation, which is E equals 1/2 CV squared. So we already have all of our values here, so we can just plug in, right? So energy is equal to 1/2 of C, right, which we previously calculated to be 6.23 times 10 to the negative 11 farads, times V, which is given to be 18 volts. Now this value is obviously squared. So we plug that in, and we get E is equal to 1.01 times 10 to the minus 8 joules. Okay, so for part C, it's kind of putting it all together, right? So it's saying that we remove the plexiglass, but don't change anything else. What will now be the energy of the capacitor? So without the plexiglass, we're no longer split in two, so we now just have one value for capacitance. So we have to use our capacitance equation again, our general one of epsilon naught times the area over D. So everything is basically going to be the same, except we are only going to be using the total area, right? So epsilon naught remains at 8.85 times 10 to the minus 12. And our area, which, by the way, if I didn't make it clear earlier, sorry, the area is just 12 centimeters squared, which would be 0.12 meters squared, which is equal to 0.0144 meters squared. Just so that way that makes sense. So we would plug that in here and say 0.0144 over our distance, which is still the same, at 4.5 times 10 to the minus 3. So our new capacitance is going to be, excuse me, 2.83 times 10 to the negative 11 farads. So now we can just plug that into our energy equation again, which, just as a reminder, is 1/2 CV squared. So energy is equal to 1/2 times our capacitance, which we just said was 2.83 times 10 to the minus 11 times our voltage, which does not change. So we just put back in 18 volts squared, and when we plug that in, we get an energy of 4.59 times 10 to the minus 9 joules, and that would be our final energy value. Thank you for listening in on my little explanation for this question.